The artificial intelligence boom appears to revolve around familiar names: NVIDIA, Microsoft, Google, Amazon, and OpenAI. But behind this ecosystem sits a Dutch company most people have never heard of. It does not design famous chips or operate a consumer brand. It builds the machines that make advanced chips possible. That company is ASML. ASML supplies lithography systems used by TSMC, Samsung, and Intel to manufacture the world's most advanced semiconductors. Modern processors contain billions of transistors powering smartphones, vehicles, data centers, and artificial intelligence. Companies such as NVIDIA and AMD design processors, but foundries must turn those designs into physical chips. One of the most critical stages is lithography, projecting microscopic circuit patterns onto a silicon wafer. Smaller patterns allow more transistors inside a chip, improving computing performance and energy efficiency. Conventional ultraviolet lithography eventually reached its limits, forcing the industry to seek a shorter wavelength. The answer was extreme ultraviolet lithography, or EUV, using light about 13.5 nanometers in wavelength. Inside the machine, microscopic droplets of molten tin are released tens of thousands of times each second. Laser pulses strike each droplet, reshaping it and turning it into plasma that emits extreme ultraviolet light. Exceptionally precise mirrors guide the light toward the wafer because traditional lenses and air would absorb it. One system contains about 100,000 components and may require 40 freight containers, 3 aircraft, and 20 trucks to ship. This is not simply a machine. It is an industrial ecosystem assembled into one system. ASML began in 1984 as a joint venture between Philips and Advanced Semiconductor Materials International. Its first operation occupied a leaking shed near a Philips facility in Eindhoven. Its breakthrough came with the PAS 5500 platform in the 1990s, helping ASML attract major customers and become profitable. But EUV transformed ASML from a strong competitor into an irreplaceable supplier. Its advantage depends on specialists such as Zeiss for precision optics and Cymer for advanced light source technology. A rival would need to recreate decades of knowledge in lasers, mirrors, materials, software, precision motion, and chip manufacturing. ASML's moat is not one patent. It is an integrated network of suppliers, knowledge, manufacturing capacity, and customers. That is why ASML remains the only commercial supplier of EUV lithography systems at scale. The connection to artificial intelligence is indirect, but essential. ASML systems are among the most critical and difficult to replace parts of that production line. As AI demand rises, ASML's production capacity influences how quickly advanced chip supply can expand. Machinery, this important, becomes geopolitical because advanced chips support civilian, military, surveillance, and intelligence systems. Export controls have placed ASML inside a global contest over who can manufacture the world's most powerful semiconductors. ASML is advancing high numerical aperture, EUV, designed to print even smaller and more precise patterns. ASML's story reveals that the greatest power may belong to the company controlling the critical tool. NVIDIA may design the processor, TSMC may manufacture it, technology platforms may deploy it. But first, microscopic circuit patterns must be printed onto silicon with almost unimaginable precision. began in a leaking ship, survived uncertainty, and invested through decades of technical failure and gradual improvement. It built a system so difficult to reproduce that the world's leading chip makers still depend on it. But underneath it is invisible light, molten tin, and one Dutch company building some of the most complicated machines ever created. That is the hidden infrastructure behind the AI boom. And that is today's billion gem.